And Dom, thanks for pointing out that I'd missed that bit. Right.
Nice.
Okay, so welcome Upper Sixth, our second last lesson. I will be period for our proper lesson when we will go over the differential equations. So so this the trapezium rule. This is a completely standalone topic. Okay, and this is really what the trapezium rule does. It allows you to work out an approximation for the area under the curve. Okay, so if you had an equation that was impossible to integrate, that with all the methods that you know, you still weren't able to work out the exact area under the curve by way of integration. This is like kind of the next best thing. And that's why you'll sort of see when you look at the formula down, which come on to in a minute, you know, it's approximately equal to this, that squiggly equal sign. So this is not an exact answer, but it will give you an approximate answer. So as the name suggests, we're talking about trapeziums, all right, or trapezia. And just to remind you, a trapezia is obviously a shape that's got two parallel sides and two non-parallel sides. And again, to remind you from GCSE, how do you work out the area of a trapezium? You average the parallel sides and you then multiply that by the distance between the two parallel sides. So if you just go and take this one up here that I've drawn here, there's a curve. And then what we've gone and done, we've got lots of trapezium underneath, trapezia, I should say, underneath it. So it kind of models the curve, but obviously the trapezia's got flat bits on top, whereas the curve is obviously curvy. So sometimes the answer will give you an overestimate if the curve, if your trapezia is sort of above the curve. But sometimes it will give you an underestimate if your trapezia are more often than not below the curve. So with this one, it would be hard to judge because it's such a strange shape. But sometimes you would get asked, would this be an over or an underestimate? And you've just got to visualize the trapezia and say, are they taking up a bigger or a smaller area than the curve itself? So anyway, so if we just get used to the terminology, we're calling h the distance between the trapezia, okay? And we're calling the heights of the trapezia, well, they're the y values, aren't they? So we're going to call those y0, y1, y2, y3, and the end ones are going to be yn minus 1 and yn. So let's just imagine we're adding all of these up one by one. So this first trapezia here has got the two sides of y0 and y1. So if you were just working out the area of that specific trapezia there, it would just be y0 add y1 divided by 2 to average it, and then multiply that by the distance between the two parallel sides. Then moving on to this second trapezia, this would have the left-hand side of that would be y1, the right-hand side of it would be y2, and you'd multiply that by h, and so on. So the last two trapezia would have, so the second last trapezia here would have sides yn minus 2 and yn minus 1, and the very last trapezia would have sides yn minus 1 and yn. So if you just picture that, so here's trapezia number 1, here's trapezia number 2, and so on and so on. If you go and factorize that, you can take out the half h, and then what are you left with? A whole bunch of y's. Now the y0 only crops up once because it is the left-hand side of the first trapezia, and you don't see it again. Whereas y1 is the right-hand side of the first trapezia, the left-hand side of the second trapezia, and so on. So all bar the first y0 and the last yn crop up twice when you factorize, because all the others are the left-hand side and right-hand side of a trapezia, whereas y0 is only the left-hand side of the first one, and yn is only the right-hand side of the last trapezia. So in short, that's how you come about the whoops, sorry, have I just lost my whiteboard? Or can you still see it?
We still see like 11.9.
I can see it.
Okay, I've just blanked it myself by accident. How do I get that back? Sorry, I was trying to move something out of the way. I just need to.
That's okay.
Let me just get it back. Okay, I've got it back now. Okay, so you can see that all right, yeah?
Yeah.
Yeah, okay, sorry about that. I've got a black box in the bottom right-hand corner that was blocking my view of it. So the trapezium rule down here, so that's, you can see where it comes about. So we're saying that the integral is approximately equal to this trapezium rule. So our half h is obviously this bit here. The y0 is cropping up once, the yn is cropping up once, but it's two lots of all the middle y values. So that formula is given. You see there, the formula is given in the formula booklet. So you just have to use it. So if this was to crop up, it's an absolute gift, because all you have to do, we look at this question here, they'll leave you a few values that you haven't worked out, so that haven't been worked out. So you literally just sub in the x value into the curve to get the y values, and then you just simply just plug the information into the formula. So just looking down here, got our half, then that is our h, so that's the distance between the trapezia there in orange. So obviously the distance between them is going from 0 to pi over 12. That's the length of pi over 12. So all of the distances between the x values will be the same. They are the h's. Obviously our y0 is 1 and our yn is 2. And then you just take two lots of all the ones in the middle. So that's two lots of the 1.035, the 1.155, the 1.414 when you've worked them out. And that is literally it, guys. Okay. So, I mean, I know you're not taking the exam, but if this had come up, you'd absolutely be laughing, because it's a gift of a question. So that then leads on, well, there's a couple of examples, but then, yeah, no, just one example. That then leads on to exercise 11I. So I think at just some point, you know, you might just want to do one or two of those, or you might want to leave it because you can just see it's so straightforward. So that takes us through. So there was, well, how many questions did we have on that? Yeah, 7 questions on that. So, you know, you might want to do one or two of those, but then I'll see you again, guys, because I want to keep the recordings separate. I'll see you again at 12:10, where we just go over the differential equations. So thanks for joining. Sorry for the hiccup in the middle.
No worries.
And, I will see you period 4.
Yeah, see you.
Cheers,
Cheers, guys. Bye.
Thank you.
Bye.
Bye.